Hello. Good afternoon.
Hello, teacher.
Good afternoon, C. Good afternoon, Pamia.
Good afternoon, teacher.
Good afternoon. Good afternoon, Pen. Wow, Pen is going somewhere, right, Pen? Isn't it raining outside? Panya, is it raining outside at your place?
No, teacher, but it's kind of dark.
It's raining so much here. Too much. It's raining after so long. I think I have to be loud with you guys because of the rain. I cannot hear. Let's wait for your friends, and then first of all, I will take attendance, okay? Or maybe...
Teacher, Michael Jackson.
Yes, Ben? Michael Jackson? What?
Nice.
Good afternoon, View. Good afternoon, Tantawi. Good afternoon. What's that? Good afternoon, Kaupong. There's so many celebrities studying in my class. I can see Jungkook and I can see Rock. Okay, I'm kidding. Well, View, it's raining outside, right?
Yeah.
Yeah, started raining. It's going to rain hard now. It has become foggy outside as well. Okay, so let's not waste time. I will take attendance, okay? And also, I will check attendance at the end of the class again, okay?
Teacher, I am present.
Oh, hold on. Okay, I will check attendance. I haven't checked attendance yet. Okay, Kan. Is Kan here? No. C is here, right?
Yes, I'm here.
Oh, C, I was about to write C here. Okay, best. Best here. Top. No, I will keep blank for now. Cao Kong. Okay, Cao Kong is here, right? Cream. Krawan. Mutta. Ja. View. Present. Pam is present. Pokpong.
Present, present.
Present. Im. Te. Panya.
Present, teacher.
Okay. Kan.
Present.
Okay, present. Oh, that one is kan. Kan kawi. Okay. Nui. Nui. Shampoo. Infar. Tawan. Guide. Kahong. Is kahong here? No. Okay.
Teacher, me present.
Who is
C.
present? What number is it?
Number 2, teacher.
Number 4?
2.
Okay, I cannot hear clearly. Okay, top? Is it top? Because
No,
reading
C.
too hard here, I cannot hear you guys well. What is it again? Can you type in the comment here? You can type in the chat box. Because I cannot hear you because of the rain. It's too loud. Okay, that's C, right? Okay, I got it. Okay. Okay. C. Okay, I'll save it. Stop sharing the screen now. So, before we get started with our today's lesson, someone just joined in. What is your name? Okay. So let's try to remember what we have learned in our last class. So what did we learn? We learned about the effects of heat on matter, right? And our main focus was on expansion and contraction. So what is the word expansion? What does the word expansion mean? Expansion means increasing in the size of an object when they become hot is called as expansion, right? And how about the word contraction? Contraction means decrease in size when objects are cool is called as contraction, right? Okay, so we have learned about expansion and contraction in all 3 states of matter. We have looked at solid, liquid, and gas, right? Okay. So have you all written this down? Let me share the screen. Did you all write this down? Everyone did, right? See. This is the particles, the arrangement of particles when heated, okay? And this is their description. So have you all written this down? Panya, did you write this down?
Yes.
Yes, right. Okay. So I want you guys to send it in the line group, okay, everyone?
Okay.
Okay, because I'm gonna check it later. Please write this down. These are the arrangements of particles, okay, in the solid, liquid, and gas when it's heated. So the description in the solid when it's heated is the particles here tends to vibrate more vigorously. That means more hardly here, okay? And second one, in the liquid, when the particles are heated, when the particles tends to move further away from each other, okay? And lastly, in the gas, the particles move faster and further apart from each other when it's heated, okay? So those are the description from our previous exercises. Okay, so let's move on to today's topic, which is about thermal equilibrium and heat flow. I think we're gonna have some time to also learn about keeping building cools, okay? I think we're gonna have time. So we will also learn one more topic, which is about keeping building cools, okay? So let's get started here. So can you see this? Thermal. So the word thermal here, right? Means the temperature, okay? Thermal is the temperature, right? And the word equilibrium, okay? The word equilibrium means something that is equal, okay? Equal is called as equilibrium. Okay, everyone? So I want someone to pronounce this word. Okay, I want Panya. Panya, can you please pronounce the word thermal equilibrium?
Yes.
I know it's little hard to say equilibrium.
Oh. Wait, again.
Okay, thermal equilibrium. Equal. It's equilibrium.
Thermal equilibrium.
Okay, very good. So very good, Panya. So it's called thermal equilibrium. The word equilibrium means equal. Okay, equal is called as equilibrium. Okay, so here in the thermal equilibrium, the heat, okay, flows from warmer objects to a cooler objects. Okay, heat flows from warmer objects to a cooler objects. So when the warmer objects, right? When the warmer objects comes in contact with another object that is cooler, right? They tend to give, okay, the warmer object tends to transfer or give the heat to the cooler object. This is how the transfer works, okay? The heat transfer from warmer objects to the cooler objects. So here in the thermal equilibrium, when the heat passes from this hot object to the cold objects, right? It reaches to the point called equilibrium, okay? Equilibrium, thermal equilibrium. So we're gonna look at that. So thermal equilibrium is a state of a system, okay? It's a state of a system in which all parts are at the same temperature. So for example, this is a cold object and this one is a hot object. So when hot object comes in contact with the cold objects, right? The heat flows and they tend to give the what? The heat to the cooler object, right? So until the hot object gives, okay, when they give heat to the cooler objects, right? They tend to meet the same temperature, okay? So for example, look here, everyone. So this one, 100 degrees Celsius, and this one is 0 degrees Celsius. That means this 100 degrees Celsius is something that is hot, right? And 0 degrees Celsius is something that is cold, right? So when they come in contact, okay, the hotter objects will give the temperature, okay? It will give the temperature to the cooler object. It will give the heat to the cooler object. So when it gives, okay, until it turns the same temperature, the hotter objects will tend to give the cooler objects heat. Okay, until it reaches to the same degree Celsius. So now the hotter object has already given the heat to a cooler object, right? So now the the both objects, right? The cooler object and hotter object has been in same temperature. So that one is called as equilibrium, okay? Thermal equilibrium. Thermal is the temperature. Equilibrium is something that is same. So it's 50-50 here, right? So that means these two are equilibrium. Understand, everyone? Kankawi, do you understand, Kankawi?
Yes.
Okay. So let's move on to the next one. Okay, now we're gonna move on to the heat flow. Okay, so heat flow and both thermal equilibrium is little connected to each other. Okay, so heat flow. Heat flow. Okay, heat only flows from hotter objects or places to a cooler object or a places. Okay, so we're gonna look at some of the example on how the heat flows from hotter objects to a cooler object, okay? So for example, this one, okay, let's say example, a boy, okay? He takes his hand away from a kettle because the boy feels the heat of a kettle. So kettle is already hot, right? So the boy, he tends to, I think he already tried to put his hand on the kettle. So when he put his hand on the kettle, what happens? The heat is being transferred from the kettle to his hand, right? So here, the heat is transferred from the kettle to the boy's hand. That is how heat transferred from one object to another object. Okay, another example is ice here, okay? So here, what happens? When you keep an ice cube, okay, on your palm or on your hand, okay? The ice tends to melt, right? The ice melts when it is in the boy's hand. The boy's hand is cool now. What happens when it melts, when the ice melts? Our hand also becomes cool, right? So that means, okay, heat is transferred from the boy's hand to the ice. Okay. Understood, everyone? So heat is always transferred from hot objects to the cooler objects because his hand is already warm, right? That's why the ice cube is being melted here. Understand, everyone?
Yes.
Okay.
Yeah.
Okay, very good. Let's go to the next one now. So here, heat can be transferred, okay, in 3 ways. Okay, so I want someone to read these 3 ways that heat can be transferred. What are the 3 ways? Pukpong. Hello, Pukpong.
Teacher.
Yes, can you please read these 3?
Conduction.
Very
Convection.
good.
Rendition.
Okay, very good, Pukpong. It's conduction, convection, and radiation are the 3 ways heat is being transferred here. All right? Okay. Now, let's move on to the next one. Pokpong, what are you doing? Teacher can see you. Are you playing games?
No.
No.
The flow of a hard energy strong solid such as metal is called ring conduction.
Okay, very good, Pokpong. Okay. So first one, conduction. The flow of a heat energy through solid, okay, such as metal, okay, is called as conduction. Heat flow from the energy through solid, okay, remember, through solid is called as conduction. So here is the example, okay. So when a pen is heated, this is the example of conduction. When a pen is heated, okay, the molecules, so there is molecules inside, right? So molecules at the bottom of the pan started to vibrate energetically. So when we heat something, do you guys remember solid in solid, when we heat the solid object, it tends to vibrate, right? Energetically or vigorously. It tends to move vigorously, right? So that allows the heat to pass through, okay? So in that way, the heat energy, it travels to the pan and then to the food inside the pan and let the food cook. Okay, understand everyone? So here, the pan is being heated, and when it heats, the molecules inside the solid will tend to move. So in that way, the molecules, right, when it gets heated, it will pass the heat to the food, and that's how the food is being cooked, okay? Now let's go to the second one, the example, okay? Example of conduction. So the first example here is the hot coffee, okay? So the heat from the hot coffee makes the cup itself hot. So this is the example of conduction. The heat is being passed through the solid objects, right? And second example is the metal spoon. So metal spoon, okay, becomes hot from the boiling water inside the cup. Here again, the heat is being passed through the solid object. Solid object here is the metal spoon. Okay, understood everyone? Now we're going to move on to the next one. The second one, which is conviction. Okay. Conviction is the movement. Okay, hold on. Okay, convection is the movement that transfers heat within fluids or air. Okay, and also you can look at the description in your book, also in page number 77 as well. Heat transferred through the movement of particles of fluids. So it only occurs in fluids, okay? The fluids can be the liquid and gas, okay? So heat transferred by the currents, okay, within the fluid or the gases. So here, the fluid here is the liquid here, okay? The liquid or the water here inside the pan. So here, when the water is getting heated, what happens? The molecules of the cold water, okay, the cold water tends to move down, okay, whereas the hot water tends to move up. So these are the convection currents, okay. The hot water tends, the cold water tends to sink, whereas the hot water tends to rise up, okay. Understand everyone? This is convection. And this is the example of convection. The air movement in our home, okay, is also the example of convection, okay? And another example is pot of a heating water is another example of convection, okay? This is the air inside our room. Inside our room also the hot airs will be up, okay? Whereas the colder air would be down here. Same goes for the water inside the pot as well, okay? The hot water tends to move up and the cold water tends to sink down, okay? So these are the two examples of convection. Third one is radiation, okay, everyone? Third one is radiation. So this is called as radiation, right? The currents flowing here is called as radiation. So the heat from the wood, right? The heat from the fire radiates and gives out the heat, right? So the process where the heat energy travels through an empty space, okay? Empty space or a vacuum is known as radiation. Empty space or vacuum is known as radiation. So radiation, what happens is it emits. The word radiation means to emit, to give out the energy, or it can be the light, it can be heat energy, okay? And the form of rays or wave is called as radiation, okay? So the radiation, okay, it does not require matter to transfer thermal energy, okay? The radiation does not require matter to transfer thermal energy. So these are the example of radiation, the sun and the fire. Okay, the thermal energy radiates through space from the sun. Okay, so this is the example. And another example is thermal energy radiating through air from a fire is the second example, okay, of radiation. Understand, everyone?
Yes.
Okay. So this one is the differences, okay? The energy, in the conduction, the energy is transferred by direct contact, okay? Through the solid objects, right? And convection is energy transferred by the mass motion, okay? The mass motion of molecules. So it usually happens in the air and also in the water, okay? The fluids. So the warmer ones will tends to move up and the colder ones tends to sink down, okay? And in the radiation, the energy is transferred by electromagnetic radiation. So these are the radiation. It moves out into the space, okay? Or vacuum. Okay. So with this, we are done with heat flow and thermal equilibrium, okay? So next topic, we're going to move on to this topic, which is about keeping building warm, okay? So the heat flow in the building is very important, okay, in order for the occupants to feel comfortable. So at our home, it's very important to let the heat flow, okay? The colder, the fresh air can come in and then the unfresh ones, right? Let's say for example, if you cook in the kitchen, right? What happens? You want to let that air go out, right? We're going to see the ventilation, the traditional house and ventilation in modern house as well, okay? So first, let's look at the word ventilation means, okay? A system or a means of providing fresh air is called as ventilation. Okay, so every houses nowadays have ventilation and even the traditional houses also have ventilation, okay? But nowadays one is more advanced, okay? So here, a building, right, can be cooled by having a good ventilation system. We need to have good ventilation system in order for the air to pass through, air to circulate in the building. Okay, so it gets continued. Okay, so a building can be cooled by having a good ventilation system so that the air circulation in the building is continuous. Okay. A hot air from the building flows from the top and cooler air can flow from the bottoms. The hot air will circulate, okay, on the top and the cooler areas will circulate down in the bottoms, okay? Goes like this inside the room. So it's very important for us to have a good ventilation system in order to have the air to flow, okay? So this is the ventilation holes in the olden time, okay? So most of the houses, okay? Most of the houses, traditional houses, are built with the ventilation holes, okay? At the base of the house or at the bottom near the roof, at the top near the roof, sorry. So these are the ventilation holes, okay, everyone? Ventilation holes. So these ventilation holes are, where do you see these ventilation holes? We can see this in traditional houses, okay? We can see this ventilation holes in traditional houses, but we don't have it in the modern houses. So in the modern houses, the ventilation holes, ventilation system is going to be another one, okay? So in the modern houses, okay, the ventilation system will be something like this, okay? We can usually see this in the kitchen as well, right? In the modern buildings, you can usually see this in the kitchen. So in the modern building, the ventilation system is made more effectively by installing exhaust fan or extractor fan, okay? These are the fans. And also in the modern houses, it is equipped with the fans and air conditioner to make our houses cooler. So nowadays we have this, right? The air conditioner. So we don't need the ventilation holes anymore, okay? So why do you think we keep this ventilation? Why do you think we keep this air conditioner here on the top? It's because, do you remember the hot airs will always be up here, right? And the cooler air will be down here. So they want to have the cooler air to pass first up here. That's why it's being placed on the top. Okay, so this is it, everyone. So I want you guys to turn to page number. Everyone turn to page number 81. Do you guys understand? We have remaining 8 minutes. So I will read out the instruction, okay? Fill in the blanks with the words given below, okay? So in the boxes, we have how many words? 8 words, right? So these are the answer to these questions down below here, okay? So I want someone to read, where is C? Hello, C. Okay, how about Te? Where is Te? Te, are you there, Te? Cao Kong. Cao Kong. Okay, guys. Say something, okay? So I will read out the words in the box here, okay? So it's conduction, conviction, high, flow, comfortable, ventilation, sink, and rise, okay? So these are the 8 words here in the box. So first one, I'll read out the question and you will answer me, okay? A, water is boiled in an electric kettle, okay? The heat from the heating elements in the electric kettle flows to the water by, what is it? Is it conduction, convection, high, flow, comfortable, ventilation, sink, or rise? What is it? What's the answer here? The water is boiled in an electric kettle or electrical kettle. So the heat from the heating element in the electric kettle flows to the water by convection, okay? B, let's see how many minutes we have. We have 5 minutes, okay? B, in the convection current, okay? In the convection current, hot particles dash and cold particles dash. Kankawi, what's the answer here? In the convection current, hot particles, do they move, rise up, or do they sink? The hot particles will, what is the answer? It will rise, okay? And the cool particles will sink. Okay, Kankawi?
Okay.
Okay, for the C, question C. Heat is transferred by dash when frying noodle in a wok. Heat is transferred by, is it conduction or convection here? Who knows the answer for this? Panya, what's the answer for this, Panya? Heat is transferred by dash when frying noodles in a wok.
Yes, teacher.
Is it conduction or convection? The answer here.
Conduction.
Okay, so the answer is correct. Very good, Panya. So it's conduction. Heat is transferred by conduction when frying noodles in a wok. D, air conditioner should be placed dash on a wall. Do we place the air conditioner up or do we place down? A view, what's the answer here? View? Do we place the air conditioner high up or do we put it down? Where do we usually keep the air conditioner? Where is it usually placed? Is it placed high, air conditioner, or is it placed low? Okay, everywhere when you go, yes, high, okay. Everywhere when you go, even at your home, the air conditioner are placed high up on the wall. E, some rooms have dash holes and windows to keep them cool. So do you guys remember the traditional houses? Okay, the traditional houses have ventilation holes and windows to keep them cool, okay? F, I want someone to read. Pokpong.
Yeah.
Pokpong, can you please read F, question F?
Heat in a building is important in order of the
Occupants.
to feel.
Dash, right? Okay. So occupants means the people who live in the building, okay? Is called as occupants.
Follow.
So heat, yes, not follow, okay? Heat flow. Heat flow in the building is important in order for the occupants to feel comfortable, okay? Heat flow in the building is important in order for the occupants to feel comfortable. So this is it, everyone. So we have, let me check the time here. Okay, we have 1 minute, 1 minute 30 seconds. So if you are done, you can take a picture of this and I want you guys to send it in the line group because I'm gonna check it. You guys, I don't see you guys sending the work in the line group. We have line group, right? See,
Yes.
teacher CK, right? So please send it there, okay? When you're done, please make sure you send your work there. And later on, I will check it. Okay, so everyone done? Should I stop sharing? Kamkawi, are you done?
Yes, teacher.
Okay, so I will stop sharing the screen, okay? So this is it, everyone. So have a happy weekend, everyone, and I will see you guys next Friday. Take care, everyone. You may leave the class now. Make sure you send your work. Okay, bye-bye.
Thank you, teacher.
Yeah, bye.
Pardon.
Okay. Pokpong. Pokpong, you can leave the class now. Kau Kong Inte.
Hả?
Bye bye, Pokpong.
Em mà được chưa?